Bunsen burner, a pendulum. Can you think of 3 or more objects that have the same common link? Now, we haven't really talked about energy conversions, but we will. We're going to take notes today on chapter 9. First of all, does anybody know what a Bunsen burner is?
No.
Wait.
Sabrina?
Is it like use electric or something? I don't know. It's a science burner that you use to like heat up.
So it's like basically like a hot plate. It's a Bunsen
Is
burner.
it electric or a hot
Bunsen burner is not. It's used by gas.
Okay.
It looks like a candle. Looks like a candle wick or a candlestick, and it has a hot flame that comes from it. But it's basically used with gas and a match to light it up. Energy conversions. Let's talk about energy conversions. Energy conversions. Now, when you go to McDonald's or if you go to Burger King and you get your favorite burger, you don't really think about, well, you should think about where it comes from, but you really don't care at the time. You just want to eat, right?
Right.
All right. So, do you know where burgers come from? What animal, right?
Cow.
Come from a cow. Do you think about what that cow eats?
Grass.
Do you think about how that grass came? How does grass grow?
Fertilizer.
Fertilizer. What's the main thing that grass?
Water. Right.
Water is one. Sunlight. You remember you learned about photosynthesis in the 7th grade?
Photosynthesis.
All right, you remember that you learned about photosynthesis in the 7th grade? You have chlorophyll, you have endoreticulum, you have the vacuoles. All of those things help to grow, make plants grow, right? So do you think about all of that when you're eating a burger?
No.
No, you don't. You just want to eat the burger. So energy conversion comes from sunlight, which is light. Light, when that cow eats that grass, that gives the cow energy, and then that cow, unfortunately, has to be put down. Nicer word. And then that meat from that cow, we eat it. So that gives us what?
Nutrients and energy.
It gives us chemical energy because our bodies are made up of all chemicals. Your body is mainly made up of 70% water, but you have carbon, you have phosphorus, you have nitrogen, you have all types of elements inside of our body. So when that cow, when you eat that food, it gives us chemical energy. That's an example of what energy conversion is. So you get light energy, chemical energy. And there are several different other types of energy that we're going to take notes on real quick today. I am passing out your forms of energy. It's only 2 sheets back and front. I want you to take one. I'm going to put your notes on the overhead projector, and you're going to have to write in the missing words for your notes. And this is going over the different forms of energy. Let me take one and pass it over. Take one and pass it down. Take one and pass it down. Now let's go over real quick the energy graphic organizer that I just gave you, the very first sheet.
I'm back.
Let's go over the graphic organizer as a class real quick. This sheet right here, take that one out. All right, so does everybody have this sheet?
Yes.
All right, let's go over that real quick. The very first one, where it says exists in 2 states of energy, there's 2 different forms of energy. There's kinetic energy and there's potential energy. So in this box, you need to put kinetic energy, potential energy. All right, everybody has that? No. Kinetic potential. At the bottom where it says can be converted but not destroyed, can be transformed or changed but not created nor destroyed, is the law of conservation of energy. You need to write the whole thing down. The law of conservation of energy. In your textbook, I think it's on page 244 in your textbook, in blue, there are different forms of energy. There's nuclear energy, chemical energy, mechanical energy, thermal energy. Those need to go in these boxes. There's 6 boxes. Energy has several different forms. Write those titles, and we're going to learn about the different forms of energy. From 244 to 246. So you have chemical, thermal, light, sound energy, and nuclear energy.
Electrical.
And electrical.